Now next is kinds of functions. First is one function. This is also called injection. Now, if function f defined from a to b is said to be 1, if fx1 is equal to, or you can say that is said to be 1, if different elements in X have different images in Y, where X is the domain and Y is the codomain. That is, if function f defined from a to b is said to be 1, if different elements in X have different images in Y. That is, fx1 is equal to fx2 if that implies x1 equals to x2 only, then fx is 1. That is, it is 1 to 1 here. So through the Venn diagram I can show this as it should be like this. This is called your 1 function, or is your injection here. Now for example, let f be a function defined from R to R given by fx is equal to x cube plus 2. So we have to see whether this function is 1 or not. Now let x1, x2 belongs to domain of the function. So exactly through the same steps, fx1 is equal to fx2. This implies that x1 cube plus 2 is equal to x2 cube plus 2. So this implies that x1 cube minus x2 cube is equal to 0. Now a cube minus b cube implies that a minus b into a square plus ab plus b square is equal to 0. This implies x1 minus x2 is equal to 0, as x1 square plus x1 x2 plus x2 square is always positive. It's always greater than 0. It cannot be equal to 0. So this implies that x1 is equal to x2 only. Therefore, function fx is 1 here. That is, it is 1 to 1 here. Right? Now, similarly, consider another example. Let's say there is another question, that is, f is a function defined from z to z given by fx is equal to x square plus 1. So we have to see whether this function is 1 or not. Let x1, x2 belongs to domain of the function, which in this case is z. Z means set of integers here. Now fx1 is equal to fx2 implies that x1 square plus 1 is equal to x2 square plus 1. So this implies x1 square minus x2 square is equal to 0. So this implies that x1 minus x2 into x1 plus x2 is equal to 0. You can see that there are two options, x1 is equal to x2 or x1 is equal to minus x2. Since these are two options, so therefore this function is not 1. So this implies that fx is not 1 here. Now, always through the graphs, your understanding is better. Now, so if I want to understand the graph of 1 function or the function which is not 1, for example, let f be a function defined from, that is your R to R given by fx is equal to mod of x. So if I plot the graph of y is equal to mod x, we have already discussed what is the graph of mod x here. So this is going to be the graph of y is equal to mod x. So whenever for the one-one function or for not to be one-one, you always draw a line which is parallel to x-axis. If it cuts at more than one point, if it cuts the graph at more than one point, then it is not one-one. So you can see here through these two values, you get the same values of y, which clearly shows that it is not one-to-one function. So particularly when we have to solve the questions for the JEE Mains or JEE Advanced. So draw a line parallel to the x-axis. If it cuts the graph at more than one point, then we will say that this function is not one-one function here. Now next is onto function. This function is also called surjection. A function f defined from x to y is said to be an onto function if every element in y is an image of at least one element of x. Every element in y is an image of at least one element of x. So what do you mean by that? So that means, let's say it is like this. So which means, can we say that if code main is same as the range, then the function is onto? That is, if the code main is same as the range, then the function is an onto function or is surjection. So if a function is not an onto, then it is an into here. If a function is not an onto, then it is into. Into means code main is not same as the range. This way, this function will be an into function. Now, so for example, we have to check whether the function defined by R to R given by fx is equal to x cube plus 2, whether this is onto function or not. Now you can see here we have y is equal to x cube plus 2. Now this implies y minus 2 raised to power 1 over 3 is equal to x as x belongs to R. So corresponding to every x belonging to R, there exists value of y in the code main. That is, for every x belonging to the domain, for every x belonging to the domain R, that is domain, there exists y belonging to the R, that is code main. So therefore code main is same as the range, hence the above function is an onto function. That is, the above function is an onto function. Now similarly, let's say let f is a function defined from R to R given by fx is equal to x square plus 2. So we have to see whether this function is an onto function or not. Now we have y is equal to x square plus 2. Now y minus 2 is equal to x square. As x square is greater than or equal to 0, this implies that y minus 2 is greater than or equal to 0. This implies y is greater than or equal to 2. So therefore the range of this function is 2 to infinity. Now codomain is R. Since codomain is not same as range, therefore x square plus 2 is not an onto function here. That is, this function is not an onto function, right? If codomain is same as the range, then it is an onto. If it is not same, then it is not an onto function. Next is bijection. Now a function which is both 1 1 and onto is called a bijective function. That is, a function which is both 1 1 and onto is called a bijective function. Now for example, now we have to show that f is a function such that x belongs to R, x belongs to -1 to 1, and given by fx is equal to x over 1 plus mod x, where x belongs to R is 1 1 and onto function. We have to show that this function is bijective function, that is both 1 1 and onto. X belongs to R such that x belongs to -1 to 1. So in this interval we have to show that this is 1 1 and onto. Now you can see here it can be written as x over 1 plus x if x is greater than or equal to 0. It is x over 1 minus x if x is less than 0. So whenever modulus is there, you need to define mod of x. So mod of x is x if x is greater than or equal to 0. It is minus x if x is less than 0. Now let x1, x2 belongs to the interval 0 to 1, because it should lie between -1 to 1. I am considering the first case first. So fx1 is equal to fx2 implies x1 over 1 plus x1 is equal to x2 over 1 plus x2. If you cross multiply the terms, x1 plus x1 x2 is equal to x2 plus x1 x2. So this implies that x1 is equal to x2 only, implies that it is 1 1. Similarly let x1 x2 belongs to, what is that, -1 to 0. So fx1 is equal to fx2 implies that x1 over 1 minus x1 is equal to x2 over 1 minus x2. So this implies x1 minus x1 x2 is equal to x2 minus x1 x2. So this implies that x1 is equal to x2 only, implies that 1 1. So which clearly shows that this function is 1 1 function here. Now we have to show that this is onto also. Now when x is greater than or equal to 0, we have y is equal to x over 1 plus x. Just to find the range of this function, we will write down x in terms of y. So cross multiply the terms, y plus xy is equal to x, y is equal to x minus xy, which is your x into 1 minus y. This implies that x is equal to y over 1 minus y. So as x is greater than or equal to 0, this implies y over 1 minus y is greater than or equal to 0. This implies y over y minus 1 is less than or equal to 0. This implies that y belongs to 0 to 1. Similarly, when x is negative, this implies y is equal to x over 1 minus x. So this implies y minus xy is equal to x, or y is equal to x into 1 plus y. This implies x is equal to y over 1 plus y. As x is negative implies y over y plus 1 is negative, implies y belongs to minus 1 to 0. So from first and second, y belongs to minus 1 to 1. That is, codomain is same as the range, which shows that the above function is bijection, or it is a bijective function, that it is both 1 1 and onto. So this way we have to consider the different cases just to show that the function is both 1 1 and onto here. Now next is, again consider again another example, that is your f is a function defined from R to R given by fx is equal to x cube plus x is bijection. So that is, we have to show that it is both 1 1 and onto. Once again, let us take x1 x2 belongs to, that is your R. fx1 is equal to fx2 implies x1 cube plus x1 is equal to x2 cube plus x2. So this implies that x1 cube minus x2 cube plus x1 minus x2 is equal to 0. So this implies x1 minus x2 into x1 square plus x1 x2 plus x2 square plus x1 minus x2 is equal to 0. So this implies, if I take x1 minus x2 common, it becomes x1 square plus x1 x2 plus x2 square plus 1 is equal to 0. As x1 square plus x1 x2 plus x2 square is always positive, implies x1 square plus x1 x2 plus x2 square plus 1 cannot be equal to 0. So therefore, from first only possibility is that x1 minus x2 is equal to 0, that is x1 is equal to x2, implies that this function is 1 1 here. So you have to do all these steps to show that this function is 1 1 function. Now for onto function, as x belongs to R, therefore for every x belonging to R there exists y belonging to R. Y means, that is, range is whole of the real line. Since codomain and range are same, so therefore fx is equal to x cube plus x is a bijection here. That is, this function is bijective function here, right? So consider another example, that is your f is a function defined from R to R given by fx is equal to mod x. We have to see whether this is 1 1 and onto or not. Now, because mod of x is greater than or equal to 0, therefore y is greater than or equal to 0, therefore range is closed interval 0 to infinity is not same as the codomain. therefore not an onto function. Now, because fx1 is equal to fx2 implies that modulus of x1 is equal to modulus of x2, that implies x1 is equal to plus minus x2, implies not 1 1 function. So therefore this function is neither 1 1 nor onto, that is, it is not a bijective function here. Now next is composite functions or composition of a function. Now next is composition of functions. This is also called function of function. Let f be a function defined from a to b and g be a function defined from b to c. Then if we are able to define, that is, g of fx, a function defined from a to c, is called composition of a function. That is, g of fx defined from a to c is called composition of a function. Now what do you mean by this? You can see here f is a function defined from a to b, g is a function defined from b to c. That is, for every x belonging to f, there exists fx belonging to that is, for every x belonging to a fx belonging to b, and from here we have g of fx, that is, you're belonging to or it's a function defined from a to c here. So that is, g of fx is defined only if, that is, your range of f is a subset of domain of g. Range of f is here, domain of g is here. If range of f is a subset of domain of g, only then g of fx will exist. Similarly, f of gx will exist only if range of g is a subset of domain of f here. Now, for example, f is a function defined from R to R given by fx is equal to x square plus 1, and g is a function defined from R to R given by gx is equal to, what is that? It is sin x. So we have to see whether f of g and g of f exist or not. Now, for f of g to exist, range of g is a subset of domain of f. Now fx is equal to x square plus 1. So you can see here domain of f is R. Now as y is equal to x square plus 1, this implies x square is equal to y minus 1. As x square is greater than or equal to 0, this implies y is greater than or equal to 1. So therefore range of f is 1 to infinity. Now gx is given by sin x, domain of g is R,